Hello, welcome to another class with Physics Anchor, and today we'll be solving more questions under electricity for those students that will be writing UTME or JAMB. So let's get to work. So on the board we have just a question, and this question is a unique one. We have three diagrams being given, and we have been asked to find the largest currents. So let's read. The diagrams above show three circuits. The internal resistances of the batteries are negligible. Which of the currents is the largest? Okay, so we have diagram A, diagram B, and diagram what? C. So which of these currents is the largest? We have I1, I2 here. I2 is flowing through this. I1 is flowing through this. I3 is here. This is I3. And we have I4, I5. So we have 5 different currents. And they want us to find the largest. So you can do this very fast if you understand the parallel connection of resistors and what? Series connection of resistors. So let's analyze diagram by diagram. In diagram A, we already know that what? Since these two resistors are connected in parallel, so different current will flow through them. That's I1 through 2 ohms, I2 through 1 ohm, but they will have the same potential difference. This 10 volts belong to what? To the two of them. So in other words, I can say that V equals to IR, my Ohm's law. So I1 will be equals to V that is common to them over R1. And that is what? I1 equals to V that we have here is 10 over what is the resistance? Resistance is 2, and that will give me 5 ampere. For I2, my I2 will give me, okay, the same V over R2. And what is that voltage? The same voltage, but different what? Resistance, which is what? 1 ohm. And that will lead to what? Lead us to having 10 ampere, which will be what? Different current. So I1 is 5 ampere, I2 is what? 10 ampere. Very fast, I can go to what? The circuit B. The circuit B, the two resistors here, they are connected in series. And what does that mean? It means that what? Same current will flow through them. And that's why we have only one current there, which is what? I3. For us to get this I3 we use V equals to IR, and that will be I equals to V over R total. So the R total here will be series connection of these what? Resistors, which is addition of what? The two of them, and we have the voltage. So that will be 20 over, okay, I have 2 plus 1, my resistor in series, and that will be 20 over what? Over 3. So that's what I'm going to have. So we can say that is about saying 6.67. Okay, that's 6.67 ampere, and that is what? I3. Okay, right, so that's about 6.67 ampere. So we have gotten our I3. So let's quickly calculate our I4. That's going to the circuit what? C. So C now, the same thing, the same way we have here, in the sense that if you look at the connection of the resistors, they are in parallel. So same, okay, voltage, but different currents. So the same way we did this one is how we are going to do V equals to IR, okay, okay, 4. I4 will be equals to V over R4. And our V here is 20. So what is our R4? The R4 is having what? The resistance of what? 2. So that will be 20 over 2. That will be 10 ampere. So let's calculate our I5. Our I5 here will also be V over R5. And that will be V. Our V is 20. V is 20. Our R5 is 1 ohm resistor. So that is 1. That's equals to 20 amperes. So clearly look at this now and go back to the question. Which of the currents is the largest? Okay, when you look at this, I1 is 5, I2 is 10, I3 is 6.67, I4 is 10 amp, and I5 is 20 ampere. So clearly we can see that what? I5 is actually the largest, and then we say that what the correct option is what I5 is the largest. Okay, so intentionally I put option here so that you can see A, I1, B, I2, C, I3, D, I4, E, I5. So your correct option here is going to be what? Your E, which is I5. I hope you understand what we just did in the class right now. So please uh, just go through the videos again and again, watch previous videos I've actually dropped on under this topic for you to actually assist in understanding questions under electricity properly. I urge you to please share these videos with students around you, especially those that are actually writing a JAMB, so that they can also benefit from what we have done in the class today. I want you to hit the like button and please comment. Let me know that you're actually enjoying studying with our physics anchor. So till next time, I'll be making another video. I want you to please be diligent in studying. Bye for now.